So metal casting is basically a process where you make the product of your particular desire by preparing a mold using a pattern which is a replica of the product, and then by pouring molten metal into that mold. So basically you will find two different ways of metal casting, one being the traditional or the conventional way of casting, that is sand casting, and another one being a slightly advanced form of casting which uses a permanent mold, which is called as permanent mold casting. And permanent mold casting is a technique where you don't have to rebuild the mold. The mold is always kept intact, and there the pattern, instead of the pattern we are using a die or the permanent mold. So in this window you can see the experimental arrangement for sand casting. So here you can see the two halves of the sand mold, one being the cope, another one being the drag, and the core placed at the center of the molding flask. We call this entire arrangement of casting molds as molding flask, and there can be 3-halved or 4-halved molding flask as and when the size of your product changes. Usually we will refer to experimental setups by just two different segments of molding flask, one being the upper one being the cope and the lower one being called the drag. And here you can see the molten metal which is held in a ladle, and this is the simplest way of transferring hot molten metal into the sand cast or sand mold. And the sand mold, we have different parts which we will be discussing in the coming slides. So like we had discussed, sand casting is one of the best technique of manufacturing and most widely used process in casting, because we don't have much investment in the case of sand casting. We just require the proper casting sand, and sand being having a very high heat capacity can be used to cast any particular material. So nearly all alloys can be sand casted, including metals with high melting temperatures such as steel, nickel and titanium, and even the size can be varied in the case of sand casting, but we usually prefer sand casting for bigger products and where we have to reduce the cost, because if you are going for a permanent mold casting, we need a die or the mold to be made of a material which is having higher melting point compared to that of the molten metal being poured. Otherwise, the metal that is being poured, the temperature of that metal will so the temperature of the metal being poured, that is the molten metal, if the melting point of that metal is very high, then when you pour the molten metal, that temperature will affect your mold quality and can even melt down the inner surface of your permanent mold. So in such cases you will have to invest more on the die or the permanent mold. So in order to avoid that, we can always go for sand casting. And here you can see the arrangement of a sand casting molding flask, starting off with the molding flask, that is the cope and the drag, the upper half called as the cope and the middle half, the bottom half called as the drag. And in cases where you have a product of larger dimension, we can have another one or two segments called as the cheeks. The cheeks being the inner segments of your molding flask. Then you will have an imaginary line known as the parting line which separates the cope and the drag, and we usually have the molding cavity known as the sand mold with a core in case the product is a hollow one, and core is again made of particular sand known as core sand. Then we have another special arrangement for sand casting, that is a runner and the sprue. The sprue is the area or the part or the term used to refer the part through which your molten metal is poured, and it reaches the mold cavity through a runner in order to make sure that there is uniform flow of the molten metal. And once the mold cavity is filled, the excess molten metal will rise up through the open riser. And to make sure that the mold is compact, we ram the sand into the molding flask. So the entire operation takes up some time, and it is done with very high care, so as to ensure you reduce the material wastage. And casting is a technique where the material wastage can be minimized, since the excess material can always be reused. And in case of sand casting, the sand can be reused by special treatment given to the molding sand. In case it is a wet sand molding, you require very less effort to reuse the molding sand. Now we will come across certain keywords which are associated with sand casting. So like I discussed, the basic keywords which comes under sand casting are, one being the molding flask. So it can be basically a metal or wooden frame, or any particular material can be used to make the frame. And usually there are two different halves of the molding flask, one being the cope, that usually is the upper half of the molding flask, and the lower one called as the drag. Why? And you can easily remember these terms by the drag being always the one which you pull down or which will be on the lower side, and the cope which is laid over on the upper portion of the drag. And like I said, for a larger size products, you will have intermediate sections known as cheeks. This particular word which I would like to bring into your attention is the pattern. So in sand casting, we always require a pattern to make our product, and pattern is usually the exact replica of the product. But since we have certain limitations or certain allowances to be given in the case of our product, because we cannot assure 100% surface finish or 100% finish to the. So pattern is an exact replica of our product. So like I said, there will be certain allowances to be given, and the pattern cannot always be the exact replica. So in order to consider all those allowances, like the distortion allowance, the machining allowance, the one called as shrinkage allowance, tapping allowance, then there is different kinds of finishing allowance, machining allowance, all such allowances. After considering all these, you need to make sure that your pattern satisfies the product, and usually the dimensions will be plus or minus, say maybe microns or maybe millimeters in difference with the exact product, and those differences can be taken in the tolerance range. Now we have another term known as the parting line. Like I said, it is an imaginary line that divides the two halves of the molding flask, or the cope and the drag. Then the next is molding sand, and like I said, the molding sand is the one which is used to make the mold cavity. We place our pattern inside the molding flask, and then fill up the remaining portion using our molding sand, which is usually a mixture of silica, clay and moisture. And in cases where we require additional permeability and such special characteristics, we go for binders and additives in the molding sand. Few other key terms which I have already given in your reference material are facing sand, core, pouring basin and sprue. These are all very minute areas which we need to pay our attention into. Facing sand is usually a carbonaceous powder or charcoal dust which is used to make sure that the product comes out easily rather than sticking onto the molding sand layers. If you sprinkle say an amount of carbonaceous dust or charcoal dust into the mold cavity, you can bring out the product easily, and also will ensure a finer or a good finish on the surface. Then core, which is used to make hollow objects, like you need a cylinder or a cup shape, you can use it to fill the cavity inside the mold, and the metal, molten metal, when you pour it, will fill the surface around this core, and core is usually made using a particular or special kind of sand known as core sand, which is more clay content. Then coming into pouring basin, this is the region, like I said, pouring basin and sprue along with the runner plays an important role in uniform flow of our molten metal. Usually when we see water falling in a puddle of sand, we see small potholes which are being formed on the sand surface. So in order to avoid such holes which are being formed on the mold cavity or on the mold, we provide a runner which is horizontal in alignment, and that runner along with our pouring basin and sprue ensures that there is smooth and uniform flow of the molten metal throughout the entire mold cavity, and only upon the completion or the filling of our mold cavity it rises off, or the excess molten metal that we are pouring rises off through the open riser. So sand casting basically involves all these following steps, starting off with pattern making. Like I said, pattern making is a tedious effort. You need to pay real good attention while making a pattern, because your pattern determines what your mold would be like, and how your mold would be like will determine what your product is. And in case your pattern is lacking the finish or the dimensional accuracy, the entire product line would be affected just because you didn't pay attention in the pattern making. So starting off with the primary step of pattern making, we go all the way till the cleaning and inspection of the castings. So pattern making, then comes the mold making, and in case we are making hollow objects, core making wherever necessary. Then comes melting of metal and pouring, which is done either using a furnace, which is a fixed one, or a portable furnace that will be discussed in the later sessions. Finally coming to cooling and solidification along with cleaning of castings and inspection. So this block diagram explains the sequence of casting. Like I said, starting off with pattern making and core making wherever needed. Then comes to the preparation of sand and mold, making the mold as per the pattern. Then pouring of molten metal after melting in the furnace. Finally into solidification and cooling, and also, like I said, the cleaning and inspection. So you can prefer this particular flow chart when you learn, and also this flow chart can be used to illustrate the process of sand casting in the exam point of view. So now we will see a slight video presentation on how the sand casting process goes about. Like we had mentioned all the sequences. Now we will see a video tutorial on the sand casting. You can see the patterns are made in the two halves. The cope and drag being placed, that is the two halves of the molding flask. The sand being filled and rammed to make it compact. Then the cope and drag halves joined together and locking pins attached. You can see the foolproofing pins to make sure that the mold is in correct position. Then the molten metal is poured through the sprue, and then metal is allowed to solidify and cool. Later on, the sand is taken off, or the two halves are separated, and the product is removed. So usually it doesn't go about all the same way. You have to sometimes shake off the sand from the cast. So that is done using a sand shaker. In automobile industries, like almost all where engines are being made, we prefer sand casting. And in industries like Ferrari or the high-end cars, they prefer handmade engines. And by handmade engines, they make single mold for an engine part, and each part or the molds are made in such a way that they can be assembled together, or the replaceability will be more. Each and every part that are being made will be of the same size, and the mold making is a very tedious effort, and they pay their full attention into the mold making. So industries such as automobile manufacturing industries, they do this casting in a very precise manner. Next particular term that I would like to introduce is a pattern. Pattern being a full-size model of the part slightly enlarged to account for the shrinkage and machining allowances in the casting. It helps in preparation of mold cavity. So pattern can be made of different materials, but usually we prefer either a wooden pattern or a plastic pattern. And in special casting process like lost form or lost wax casting, there we go for either a wax casting or wax pattern or patterns made of sublime materials which vaporizes when the heat is applied. So patterns can be of different types, starting off with a single solid pattern, the split pattern which consists of two halves, one for the cope, another one for the drag. Then there is the match plate pattern which is used in order to avoid the mold shift or like I said, the defects in casting like mold shift, that can be avoided by using a match plate pattern. And finally the easiest pattern or the type of pattern which makes casting or mold making easier is the cope and drag pattern, which comprises of all the required the components, rather than components, all the segments in a sand casting process, like the riser pattern, the cope pattern, the drag pattern, the runner pattern, the gating system, and every particular element that you require in a sand casting can be satisfied by using a cope and drag pattern. So like I said, the pattern material starts from wood to any range of material, and that depends on how well you are using your economic balance. So wood is the common material because it is easy to work and you can easily make any particular part using wood or the pattern using wood. Then comes metals and alloys, which is slightly on the expensive side, because if you are making a metallic pattern, you need to invest first on making the pattern rather than just making a pattern out of wood or plastic. Then plastic is something which compromises between wood, that is the pros and cons. When you consider wood and metals, plastic balances, or like you can see, it is a break even between the wood and metals. Also there are other materials which are being used, like I said, in the special cases of plastic, like plaster of Paris, rubber, then polystyrene, which is used in lost form type of casting, where it is a sublime material which vaporizes when the heat or when you pour the molten material, the pattern vaporizes, so it ensures precise manufacturing. Then we can use wax patterns, like in the case of investment casting, or which is called the lost wax pattern casting, and other resins. So pattern allowances, like we had seen, pattern is not the exact replica. We have to give certain allowances, starting off with shrinkage or contraction allowances. Shrinkage allowances two types: liquid shrinkage and solid shrinkage. So shrinkage, like you know, metal is being poured in its molten state. So when it cools and solidifies, we all know that metal shrinks when the temperature reduces. And that shrinking cannot be considered as a plus point in casting. So we need to compensate for that shrinkage. And shrinkage again is two types. One is liquid shrinkage, another one is solid shrinkage. Liquid shrinkage being the shrinkage elements that is given when the molten metal solidifies into the solid metal, and that is where we prefer, where we give our preference to the liquid shrinkage. But even after solidification, the temperature of the metal is high, and that temperature, when it cools down, again shrinks down the material, and that is compensated by giving solid shrinkage allowances. Then we have other allowances like draft or taper allowance, then machining or finish allowance, distortion or camber allowance, and finally the wrapping allowance. So all the first four allowances are positive allowances, and the last one being a negative allowance, because wrapping is the process where we shake off our pattern out of the mold. So when we shake off the pattern, we extend the cavity a little bit, and that extension need to be reduced, and that reduction is given by our machining allowance or the so-called finish allowance. We'll just have a pic or see the pictures of all these allowances. Here you can see the defect due to having vertical surfaces, and that can be overcome by giving the draft or taper allowance, where you can see the pattern which is given a taper and that taper ensures that there is no crack in the middle, and the end can be machined off while you finish. Then comes the camber allowance or distortion allowance. You can see the original casting here, but if the allowance is not given, you can see the distorted part or the cambered part. So depending on the material characteristic like the heat capacity and heat expansion, we need to make sure that we give the allowance in the right manner. So next we will go on to the molding sand, which like we had discussed in the introductory session, comprises of a base sand, binder and moisture. Base sand is usually silica sand, since it is very inexpensive and can withstand high temperatures, and it is different types of silica sand can be used depending on its permeability. We rather prefer sand with lower mold permeability, fine grain sand, so that it mixes and bonds highly with clay. So sand can be mixed, either hand mixing can be preferred, or in case of large manufacturing segments, we can go for a mulling machine to ensure that the mixing is done in a uniform manner with sand and clay, and also with water or other additives. And these are the constituents of molding sand. The clay being bentonite, zircon, olivine and iron silicate is used to ensure that the mold is having good strength and sufficient enough permeability. So in order to make a good sand molding or sand mold, we need to have these characteristic properties for the molding sand. One being the strength. So strength for sand mold is usually given to maintain the shape and resist erosion. Like I said, when you pour water over sand, it leaches out sand. So if you are using such kind of sand or such kind of a mold, your mold will be brittle, or you cannot ensure that, or you cannot guarantee that the mold will give out your product in the exact shape. Then comes permeability, which allows hot air and gases to pass through voids in the sand. And permeability, in order to ensure permeability, we give certain vent holes while preparing the mold, and that can avoid the entrapment of air or gases when the metal comes in contact with the sand or cools down, or rapid cooling happens. Then comes thermal stability, that is to ensure to resist cracking on contact with the molten metal. Again, these are all sand properties to ensure we have a very good quality mold, and that results in a good product. Then comes collapsibility, which allows the material or the metal to hold its texture, ability to give away and allow casting to shrink without cracking the casting. And finally, reusability, which allows the sand to be reused.